Hi, my name is Thomas Kim. This session continues from our previous session, Primality Test 1 using Wilson's theorem or factorial method. Please watch this series of videos if you want to understand current session. So in this session, we will improve Wilson's theorem or factorial method to test primality test. Please download source code from this link. Also note that we will please refer to Wikipedia about primality test and also Wilson's theorem, and we will use this website to test prime numbers in our software development. Now unzip downloaded sample, our previous sample, unzip it, then rename it, improved Wilson's primality test solution. Copy this solution to your working folder like this. Now open it in Visual Studio 2015. Now press Ctrl F5 to build. You should be able to build successfully like this. Press Enter. Then in Solution Explorer, open Wilson test and change this function name Wilson test. Okay. Then save it. int main Wilson test. Now press Ctrl F7. Okay, it works properly. So if you want to understand this code, please refer to my previous video. In this video, I explained all the details about this code. Now we will optimize this algorithm. We will add a few more header files, include CMS, include CSDDINT, include CLocale, include string. Now save. Here, template, type name T get, save, max, return T sqrt square root, double, std, numeric limits T max. Okay. This function computes square root over maximum number of type T. Okay. Now we will add one more template function. Template, type name T, bool is in safe range Tn, return, and we are using this function get safe max t like this. Okay, now we will this function tests whether n is less than sqrt of maximum value of type t. Okay, here I will copy this function then rename it bool. I would say Wilson test 0 here, mpz class n. We don't need this and here we can replace it to n like this, and we change it to p, then we don't need this. I will change it like this. Then p we are returning mod p n-1. Okay, instead of p it should be n. Like this, we fix like this, so it should be bool. If n is prime, returns true. Else returns false. So this is our first try. We have to initialize it to 1, and this is n. Okay, save it. Now we are creating another function. I will name it void Wilson test long range mpz class limit std string. I am declaring an input string, std cout input an integer in the range limit std cin input mpz class n input cstr. Okay, while n greater than 1 and n less than limit, we display n first, then std cout Wilson test n. We are calling this function. If it returns true, is a prime. Otherwise, is not a prime. Okay. Now we are copying this text. We are reiterating. Here. We don't need to declare like this. We have to fix like this. Now save. Now we disable this function. Instead, we are calling this function like this, and we have to provide the range mpz class 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 digit. Okay, now let's compile and run. Control F5, build and run. So we provide for 2. So 2 is prime, 3 is prime, 4 is not prime, 5 is prime, 6 is not prime, 7 is prime. Here we can test this number. Copy is prime. Now we are trying with 5 digit 1 2 3 4 5, or it can be 6 digit. Here we are copying this number, copy, then paste. Please wait, it's calculating. I think it is very slow, right? So I will stop it. I will improve it a little bit. I think it hang. Okay. I will close it. Then here I will improve it a little bit. Copy this part. Copy. Then paste. I would say test 1. Save it. Now I delete this part. We don't need this part. Please note that it accumulates. It becomes very big number. It becomes huge number. So we can modify code like this. We can modify like this. And we don't need this. We can put it here like this. We modified it, we improved a little bit because we shrink p1 factorial with remainder or mod n. Okay, like this. Say now build once again, right click, build. Okay, it builds. Now Control F, make it to release build, rebuild. Control F5. Now we will paste this number, copy, paste, enter. Okay, it is prime, but it is very slow, I think. Now let's try another number. Copy. Let's stop. Sorry, we have to change this to test 1. Okay, we have to change this test 1. Now rebuild. We have to change it to test 1. This is updated one. Control F5. Here, copy, then enter. Now it runs much faster, and I will put this is 7 digit. I copy any number, copy, enter. This is 7 digit, okay, and we can try 9 digit. It is 6, 7, 9 digit. Okay, it still works, but small numbers. This is the basic algorithm. This is the basic algorithm. This is the basic Wilson test algorithm. But I want to improve it for much faster using short integers. Now we will add another function. Bool Wilson test 2 unsigned long and for p minus 1 factorial unsigned long p 1 factorial. We initialize with 1 for unsigned long p equals 2, p less than n plus p. Here p1 factorial p1 factorial modulo n. This is to prevent overflow. Here return p1 factorial n minus 1. Okay. If n is prime, return true, else return false. Void Wilson test short range demo. I would say short range unsigned long and 4000 delimiter std cout in view std locale like this, std cout input an integer in the range get save max unsigned long, or you can say decl type and okay, std cin and while n greater than 1 and is in safe range and std cout and std cout Wilson test 2 and is a prime, else is not a prime. Then we have to copy this part then at this point std cout out of range n std and there I would just say out of range. Now here you can say Wilson test short range. Okay, now build it. Okay, it built successfully. Control F5. Now we can support with prompt number 2 to this is 9 digit, 3, 6, 9, then 10 digit. Okay, say 2 is prime, 3 is prime, 4 is not prime. Now here we can copy this text, copy, then it's really fast, right? Say from I copied once again. This is 6, 8, 9 digit, 6, 8 digit, and let's see. Copy. Wow, this is 9, 10 digit. It takes time. Okay, this is prime. So we compute it. So using this algorithm for short range test, this algorithm, we can compute much faster than using this long range algorithm using MPSZ class. Okay, I hope you understand this my demonstration. Please subscribe to my YouTube channel. Thank you for watching.